Okay. Put some money in saving account. What does that say? Y is how much money she has in the saving account, and she gets interest on the £4,000, and the rate of increase of Y is KY. The rate of increase of Y is KY. Okay, so write down differential equation. The rate, that there says the rate of increase of Y. Well, it doesn't. It says the rate of change of Y, but we know it's increasing. If it was decreasing, we'd put a minus sign on, even though you don't have to, because K could just be negative, but it's traditional that if something's decreasing, you put a minus and then put K, and then K is positive, but the whole derivative is negative because it's decreasing. So this says the rate of change of Y is KY. Perfect. Solve your differential equation. Okay, 3 steps. Both sides by dt, multiply both sides by dt, move anybody who's on the wrong side, whack integral signs on. Multiply both sides by dt, here it is, step 1. So that would give us dy equals ky dt, but then the k can be on whatever side it wants, it's just a number, but then you're moving the ky under. So I think it was a little bit difficult to read here. Dy by dt is that, and then you've got the divide by ky on that side but not on that side, but you've got the times dt on both sides. That would give us this, but okay, let's slow this down. We are going to multiply both sides of dy by dt equals ky. We're going to multiply both sides by dt. That would give us, no, it wouldn't give us an integral sign. It would give us dy equals ky dt. Then, step 2, we're going to get rid of anything on the wrong side. You've decided to take the k with the y, that's totally fine. You could leave the k there and just divide both sides by y, but you divided both sides by ky, so that's absolutely fine. So then, that would give us 1 over ky dy equals dt. Now notice I wrote it differently from you. It's the same thing. What you've written there, the integral of dy over ky, is the same as the integral of 1 over ky dy. They're the same thing, but this comes back to exactly what we were talking about in previous questions with that confusion over what dy actually means. And see how now you've abandoned. Now I know you know how to integrate 1 over ky dy, and I know that you know how to integrate you did integrate dt. You just forgot to take away that. Okay, but I know that you know how to integrate 1 over ky, that it's ln ky with a 1 over k. I know you know that because here's how I know. You just did here, no, previous question, here, you just integrated fractions and got ln. That's a bit higher, sorry. Here, you just did it. Fractions, you know that they integrate to ln. So I know you know how to do this, but you didn't do it. So you're not picking up marks. Why not? Why was that not done? Because your brain had no clue what that meant. Because it's not normally written like that. It's normally written with the dy on the end. And also, as we have discussed lots in this paper, where is all of the d's? So all of these discussions about all of the missing dx's, and also I think there was another question at the beginning with missing. Oh, it was on the other paper, wasn't it? On paper 1, all of those dx's and dy's, and the importance of understanding what that's doing on the end of the integral. Now, because at the moment, and this was the problem with the integration by substitution as well, by the way, because at the moment you don't have a clear meaning for that dx or dy or dt on the end of an integral, it just kind of appears or doesn't appear and is sort of irrelevant. And then when it was on the top here, obviously your brain's been like, what? We ignore it when it's to the right. What is it doing on the top? So again, same issue we've come to over and over and over, which is not unusual. This is the vast majority of students. Why? Because you haven't had your work marked every week and given feedback in this way. So how on earth would you know? You know the maths. You 100% know the maths. You've got the ability, you've got the understanding, but the way you're writing it is costing you the A grade. But no one's, I assume, ever told you that. And that's what we're working on. Working on confidence and style. And those two things are going to move you from the D to the A. So, yeah, that's what's gone wrong there. Then part C, now they tell you K. Oh my God, that's the most disgusting K, isn't it? So all the way down here, K would just be K. It would be a number. It would carry its way through like a little river through the equation, but we wouldn't know what it was because we haven't been given any fact. Oh, we have been given a fact actually. We're told that when T is naught, the investment is worth 4,000. Oh, but we could use that to find the plus C, couldn't we? Because when we integrate, we've got that plus C. Yeah. So this piece of information that they did tell us, we are going to sub that in, and that is going to allow us to find the value of the plus C. But we still wouldn't know the K because we haven't been given another piece of information. So they tell us the K. So now we know the K. So now we know the equation. You don't, because the equation comes out of here, out of integrating both sides and then rearranging and finding out what the plus C is. So I'm not sure what more you can do at this point, but let's see. During the first year, the rate of interest is 6%. Now the rate of interest is dy by dt. You know that because you wrote it here. You translated it here. The rate of interest, the rate of increase of y. Y is the investment, dy by dt is the rate of increase of the value of the investment. Okay, so they're telling you that dy by dt is 6. Oh, I'm sorry, no, I didn't read this carefully enough. Let's make it a bit bigger. They tell us K. That's what I didn't notice. K has got an R in it. So they're kind of they're telling us what the number K is, but we still have a letter in our equation that we don't know what it is, which is R, which is the rate of interest. This makes a lot more sense. Oh my goodness. So during the first year, the rate of interest is 6. So that R there is 6. So you have done that. So you've said K is this thing here, but R is 6. So I can put the 6 in there over 100. And you do be careful with your zeros though, because they really do look like C's. So earlier you had 30 over 2, and I thought it looked a bit like 32. I don't know why it looked like a 2, but definitely your zeros turning into C's. Look. Out of context, that says ICC. It doesn't say 100. So say you had, for example, if you had 10C, what would that look like? 10C. 10C and 100 would be identical. That could cause a problem. So I think try to close up your zeros. I know loads of this sounds ridiculously petty, but honestly, it is what makes the difference between a D and an A. It really is. Okay. So you have simplified that. So now you know what K is. Sub it into the differential equation with T is 90. Perfect. Exactly. Yeah. Exactly. You've got your differential equation. It had a plus C, but we used the information to find the C. Now they tell you what K is with an R, then they tell you what R is, so you put the R in, now you've got the K, you put that in your differential equation, and then it says what is the value of the investment after 90 days. That means T is 90, Y is the question mark, sub T, let's make sure that you did really get that, sub K into differential equation with T is 90 and find Y. That's what you'd be doing. Yeah, perfect. So all of those marks are, I think, all of those marks are due to the confusion about that notation. That is my claim. That is my claim. Okay, let's look at the next bit. Over 1 year, the rate of interest drops to 5%. So R is 5. Find the total amount of time that it will take for investment to double. So is R after 1 year? Oh, I see. I thought the interest rate dropped slowly. Like over, I read it as over 1 year, the rate drops. So I was thinking, well, how are we going to do that then? We don't know what the rate is on any. Are we going to have to work out? No, that's no. But it's okay. It says after a year. So we've got find the total time it will take. Oh my goodness. Okay. So we've got year 1, where R is 6, and it starts at 4,000, her investment. So we need to work out when T is 365, how much money is there actually in the bank? That's what we need to find out. Then another amount of time happens. We don't know how long, that's what we're trying to find, where R is actually now 5, and we want her investment to double from the initial 4,000. So we want it to get up to here. Well, that's not what we're trying to find. We want it to get up to £8,000. And what we want to find is how long that is going to take. And then we would have to add that time to this time, because those 2 times altogether is how long it took to get from 4,000 to 8,000. That's a hard question. Let's have a look what you did. Right, R is now 5%. So you found the new K, which would be what we'd use for this bit. 4,000 oh, I don't think you mean minus there. I think you mean like, therefore, to get to 4,000, start at 4,000, therefore to double would be 8,000. 1.06. Okay, yeah, this is the new K for our new differential equation that we would use for the second bit. Then up here, you're saying that if you've got a 6%, I can see what you're saying. If you've got a 6% rate of interest, then each year you multiply the amount of money that you started with by 1.06, then you will get the amount of money that you have at the end of the year. That is true. But I don't think in this case we need that, because we've got our equation that we found, and so maybe you were thinking towards geometric series here. But what we're going to actually do is we're going to say the investment is 8,000. What is T? We're going to be using the equation that connects Y with T, because Y is 8,000 and T is what we're trying to find. So we get that equation from solving our differential equation. This bit here, when we sub in Y is 8,000 and try to find T, you're completely correct that this would be the K that we would use. And then we would be able to find that. But then we would, in order to do that, oh my god, I'm going to have to do the question. Can't hold it all in my head. But my initial thought is that all of the problems with this question come back to the integration notation, and also that this is a hard question. Those are my 2 thoughts on this one for now.